All right, we're recording now. Go to share the screen. Okay. You're over here. So finish 3.4 and go to 3.5 today, which I think I'm going to be able to do. In fact, even with time to spare. So we'll see how it goes. So again, right now I'm able to keep the schedule, but really when I keep the schedule, I'm ahead because I've got buffer days at the end. I'm changing the assignment a little bit to 3.4. I'm throwing some stuff out. Now, yesterday I added some problems. So since I added problems, it's only fair that I throw some stuff out. So I'm throwing out the most difficult problems from 3.4. So skip 23C, 27, and 39. Again, skip 23C, 27, and 39. And yesterday it was adding on 3 through 6. It was originally 5 through 6, right? So now it's 3 through 6. So 3.4, skip 23C, 27, and 39. Okay, and the first thing I gotta do is clean up something I messed up on yesterday, which was problem number 15. Okay, so I went the wrong way for 15. Okay, so I left you last time with this graph. That was incorrect. It should be like so. So from problem 15, it started like this. And I think the best explanation I can give you right now is I had square root of x, square root of negative x, and then if I change x to parentheses x minus 3, which is the same as the original, I'm supposed to go 3 to the right. I ended up going 3 to the left. So it should be like so. And this is the point 3, 0. Okay, so if you remember from yesterday, I left it like this. This was the wrong graph. It should be like so. And the way you can double check that, of course, is by plugging 3. If I plug in 3 here or here, I get 0. And that was not going to work if I plug in negative 3, right? Negative 3 wasn't going to work. Okay, so again, I messed up for problem 15. Cross off this, and it should be like so instead. Okay. All right, so last time I left off on somewhere around 17, and we'll try to knock off some more of these. So you have your given function, and you're doing stuff to it. Okay, we're translating it, which means moving it. Okay, revolving about it, reflected across x-axis, y-axis, and stuff like that. Okay. Okay, so how about I'll show you 21, y equals negative x cubed plus 4. Let's see, what, 9? And sorry, I know you can't see what I'm writing yet, but I'll get it eventually. 3.4, page 179. Okay, 21. Y equals negative x cubed plus 4. All right, so again, you should go from the basic functions, not by plotting points, but just start with the basic function with the cubic function, and then apply your transformations to it. Okay. So, rough sketch. I'm going to put it all in one graph. Go like this. Okay, so I'll start with my x cubed, and x cubed looks like this. And now what about negative x cubed? Negative x cubed reflects across the x-axis. Okay, so this part will come down here, and this part will go up. Okay, and I'll change colors for emphasis. So this thing reflects down to like this, and this thing reflects like so. This is negative x cubed in green. Okay. By the way, when you do problems for me on the quiz or homework or exams, you don't have to have different colors if you don't want to. It's nice to give contrast, right? So you can see the different contrast. So that's negative x cubed. Okay. So 0, 0 stays 0, 0. So labeling key points like 0, 0. Okay. And now what's the effect of the plus 4? You recall what happens to the plus 4. I take the graph of negative x cubed and move it 4 units up. By the way, what tells you that is what happens when you plug in 0. Right? Plug in 0, 0 plus 4 is 4. So 0, 0 becomes 0, 4. Okay. So I just move the graph up 4 units, and that'll do it. So here's 0, 4 roughly. So I just draw the same graph as the green, except try to move it up 4 units. And there we go. Okay, so you should be able to do such a progression for me. Okay, show me x cubed, and then show me negative x cubed, and then negative x cubed plus 4. Okay, one graph at a time. Okay, it got reflected, and then move it up 4. All right, which way am I moving it? Am I reflecting it? And so on. Okay. All right, so that's 21. Let me raise it up again. You see that? Okay, now I wasn't going to do 19, but I'll just talk about it. 19, x minus 2 cubed. Your base function is still x cubed. Okay. Take your cubic function for 19. And instead of x, it's parentheses x minus 2. Can you recall what happens there? I move the graph 2 units to the right. 2 to the right this time. Right, so that's 19. I'll just talk about it. Okay, 23 has 3 parts, A, B, C. Again, I told you to skip C. So skip 23C. I'll do 23A in its entirety. Y equals absolute value of 2x. Whoops, I have that in red. I didn't want it in red. Y equals absolute value of 2x. Okay, now, for this one, I think it's worth it to show you a little mini table, as it were. So let me go ahead and make a table of x versus y. Well, how about I just go from -2 to 2? Okay. Now, if you know how the transformation works, you can just go straight to it. But I thought I'd go ahead and make a table here. Okay, plug in 0, 0, 1, 2, 2, 4. -1. 2 times -1 is -2. Absolute value of -2 is 2. -2. 2 times -2 is -4. Whose absolute value is 4. Okay, so let's just go ahead and plot that. Like that. 1, 2, 3, 4. 1, 2, 3, 4. Okay, notice I didn't dedicate any space to negative y's because I have no negative y's. Okay, 0, 0, 1, 2, 2, 4, -1, 2, -2, 4. So it's still V-shaped. Let's compare it with the actual absolute value function. Okay, so the thing that I have in green is absolute value of 2x. In red, I'll show you the actual absolute value function. So the problem is technically finished. But 0, 0, 1, 1, 2, 2, -1, 1, -2, 2. So in red, is what I have for the absolute value function. So it's a horizontal compression. Okay, it squeezes it in like so. Okay, it's originally like this, and it gets compressed by a factor of 2. Okay, you kind of scrunch it in like that. So that's what happens in this case. Okay. Okay. B, I'll just talk about it, but not do it. 23b, absolute value of x minus 4. X got changed to x minus 4. That's sort of like 19. So you take your basic absolute value function, the red one, and move it 4 units to the right. Okay. So 23b, maybe you just want to jot down in your notes. Okay. Move 4 units to the right, the absolute value function. Okay. So you should know absolute value function is V-shaped. And if you want, you can put that in your next cheat sheet, the next formula sheet, if you wish. Absolute value on page 170. There it is, right? V-shape. Or I got it over here also. Okay, so just move it forward to the right. Okay, then some problems at the end, then I'm pretty much done with the section. So 25 to 39, I'll show you some of those. And I got rid of some again already. So throwing out the harder ones. I can start some with 3.5. I will do 25, which is actually not that much different than 23b. So they give us 3 functions, absolute value function, f of x. Capital F of x is 1 over x, and g of x is square root of 1 minus x squared. Okay, so they say start with a basic function and do whatever. Okay, so 25, please. F of x is absolute value of x. You want f of x minus 5, or absolute value of x minus 5. Okay, so just a crude graph is all I need. Okay, so I start with my absolute value function, V shape. Goes up at a 45-degree angle, comes down at a 45-degree angle, like that. And what does that do? 5 units to the right. So instead of 0, 0, 5, 0. I'm going to try to draw the same thing. So there we are. In fact, I've snuck in the answer to 23b, sort of. Look back at 23b. 23b, it's 4 units to the right. So instead of 5, 0, that one would be over at 4, 0. So it would look something like this. That's basically it. Okay. Okay, and then I'll do one of each. 33. You got capital F of x is 1 over x. Doing y equals negative f of x plus 3, which is negative 1 over x plus 3. All right, so they want you to give the progression of that. Okay, so start with your basic 1 over x function, the reciprocal function, right? If you want to put it on your next cheat sheet, you may. See if I can show that back to you again. And page number what? Oh, where did that function go? Reciprocal function. Oh, looks like it wasn't even this section. It's a previous section, I guess. Oh, anyway, I won't bother to look it up. But the reciprocal function looks like this. Okay, these two branches. Okay. Well, let me just ignore the negative for the moment. 1 over x plus 3. 3 units to the left. So I go 3 left. That's not going to be easy to do here, so I'll have to have a brand new graph for that. But move this 3 to the left, move this 3 to the left, move the whole thing 3 to the left. And we'll just take key points here. This was 1, 1, negative 1, negative 1. Okay. So move this 3 to the left, move this 3 to the left, and even the asymptote moves 3 to the left. Okay. Unfortunately, I reached the bottom of my paper, so I got to go back up. But we'll try to duplicate this. So how's the new graph going to look now? Okay, so 3 to the left. The asymptote used to be the y-axis, which is x equals 0. Move it 3 to the left, it's x equals negative 3. By the way, you can tell x is not allowed to be negative 3, right? So there's a new asymptote. Okay. And the rest just goes like so. Okay. And then key points, 1, 1 becomes negative 2, 1. Negative 1 becomes negative 4, negative 1. This is what I have right now. Okay, double check. What do you get when you plug in negative 2? 1 over 1, which is 1. What do you get when you plug in negative 4? Now, negative 4 plus 3 is negative 1. 1 divided by negative 1 is negative 1. Okay. And now, there's a negative in front of the whole thing. So negative the whole thing means reflect across the x-axis. So this thing bounces down here, and this thing bounces up to here. Reflects. Okay, so I'm going to try to draw the mirror image. So this thing becomes down here. That's in blue now. I'm not sure we can see that. And this thing goes like this. So this is y equals negative 1 over x plus 3. Everything that's in blue, which is that piece and this piece. Not sure we can distinguish between the two. Maybe it's a little bit better there. So the final answer is a blue graph. 2 pieces, that one and that one. Okay. All right. Okay, then let's see. I'll show you 35. G of x minus 2. G of x is the square root of 1 minus x squared. Okay, and then once I do that, I'll talk about 37 also. Okay, and then I'll be done. Okay, so they want g of x minus 2, or square root of 1 minus x minus 2 squared. Okay, this is the semicircle function that we had a couple days ago. So let me show you that. Radical 1 minus x squared, negative 1, 0, 1, 0, 0, 1. By the way, when you plug in 0, you get square root of 1, which is 1. Plug in 1, 1 minus 1 is 0, square root of 0 is 0. Plug in negative 1, negative 1 squared is 1, 1 minus 1 is 0, square root of 0. Okay. Now, what happens if I replace x by x minus 2? That moves 2 units to the right. So this thing ends up over here. So it's just like I have another branch there, so to speak. Move it over to there. Okay, so negative 1, 0 becomes 1, 0. 1, 0 moves over to 3, 0. And 0, 1 becomes 2, 1. Okay, I'm going to piggyback off that information to do 37, and then I'll be done with the section. Look at 35 and 37. Okay, I just finished 35. 37 goes 1 minus g of x minus 2. So there's a minus sign. Okay, if you ignore the 1 just for a moment, kind of cover it up. Okay. The negative means reflect across the x-axis. And what does the 1 do? Move the whole thing up 1. Okay. So I'm going to piggyback off this graph. So 35 is finished, but as long as I got this graph, go on to 37. So and 37. So if I put a minus sign in front of the whole thing, that ends up going like this. So negative radical 1 minus x minus 2 squared, or negative g of x minus 2. Okay, so 1, 0 stays there, 3, 0 stays there, but 2, 1 goes down to negative, 2, negative 1, positive 2 and a negative 1. And now there's a 1 in front of the whole thing. 37, you're adding 1. Okay? So I know there's a lot of graphs here now. Take the green graph. The green graph goes up 1 unit, and that's your answer. Okay, so imagine taking this thing and moving it up a unit. I'll draw a separate graph for this because the picture is going to get kind of cluttered up now. Okay, but that's basically it, and that's the final graph. Okay, say, how do I do that now? Well, I'll just add 1 unit to all of these. So 1, 0, if I move it up 1, 1, 1. 2, negative 1 becomes, go up 1, 2, 0. 3, 0 becomes 3, 1. Okay. So move the green graph up 1. And that's the final answer. So this is now 1 minus g of x minus 2, which is what the problem originally wanted. y equals 1 minus radical 1 minus x minus 2 squared. A lot of stuff going on there. There we go. Okay, so that's what I have. Quick double check. If I plug in 2, that's 0. Square root of 1, 1 minus 1 is 0. I plug in 1. This becomes 1, 1 minus 1 is 0, so the y value is 1. And likewise, if I plug in 3, 3 minus 2 is 1, square root is 1, that's 0, so 3, 1. So it looks like it works. Okay. There we go. And just a quick double check, I'll quickly raise it up so you can see that in case you want to catch the video and it was blurry at first. You can look at the video later, of course, anytime you want. Right, that's it. Okay, so I'm actually done with 3.4 now. I'm ready to start 3.5. What time is it? 11:40. Okay. Right, so beginning 3.5. Methods of combining functions. Okay, don't worry about that word iteration. Okay, combining functions. The easy one is to add, subtract, multiply, and divide functions. You're given two functions. Sum, add them up. Difference, subtract. Product, multiply. Quotient, divide. Okay, sum, difference, product, quotient. That, I think, is fairly easy. What's harder, and you had an introduction to this, I think, in intermediate algebra, is something called a composition of functions. Page 183. Okay. The F circle G stuff, F circle G, F of G of X is what it means. Almost looks like fog. See where it says F circle G of X? It means F of G of X. It's called a composition of functions because you're doing a function inside a function. Okay. So just think of F, right? So behind the F, I can put a number or an algebraic expression. Since I'm allowed to put any algebraic expression, you can put, among other things, another function. So F of G of X. That's a little bit harder. So I'll be showing you examples of that also. Okay, so you see here, example 2, page 183. Here are two functions, fog and golf, F circle G of X, G circle F of X. So, well, are they the same thing? I don't know, let's try it. F circle G of X means F of G of X. Okay, so say, how do I do that? I'm getting dizzy looking at all the functions and all this. Well, by order of operations, you do the inside parentheses first. So you go innermost. The innermost is G of X. So first you change G of X to what it's equal to. It's equal to 3x plus 1, right? So notice from this step to this step, all they did was change G of X to what it's equal to, 3x plus 1. And now that 3x plus 1 gets applied to the F function. So what does F do? It squares whatever you give it. Okay. So whatever's behind my finger right now, we square it. So 3x plus 1, you square the 3x plus 1. 9x squared plus 6x plus 1. Okay, how about G circle F, golf of X, G of F of X? It's reversed. Okay, so again, by order of operations, first you do the inside, change F of X to what it's equal to. What is it equal to? X squared. So right here, change it to G of X squared. And now whatever's behind my finger there for G goes right there. It's 3 times whatever plus 1. So 3 times whatever is x squared plus 1, or 3x squared plus 1. Okay. And they're saying, notice that the two results obtained are not the same. So in general, F circle G and G circle F represent different functions. They could possibly be the same, but not in general. So F of G and G of F don't mean the same thing all the time. They could, but not necessarily. Okay. So we'll see examples of these. Okay. So we'll jump right in. 1 to 17 odd. It seems like it's not that much, but you know, there's part A, B, C, and all that stuff. So it's not as short as you might think, unfortunately. Okay. All right, so page 190, 1 to 17 odd. Okay, so 1 to 17 odd. Okay, so let me project that. So those of you that don't have the book and don't plan on getting it, show it to you so you can get it off the video later. A little bit more, get my finger out of the way there. 13, I think. Okay, 15. And 17. Oh, I guess I got some pictures and some more A, B, C there. And there's the bottom. Sorry, I can't get all of it on the same screen. Okay, so 17 has A, B, C, and the questions are below there. So that's what I can do for that. And let's see, we had to go up to 17, and that's it. Okay, so we can get started with it. All right, so they're giving you all these functions, F, G, F, G, H, K, and M, different functions. So 1, 3, 5, 7, we're not doing any composition yet. We're just adding, subtracting, multiplying, and dividing. Okay, that shouldn't be too bad. Okay, so how about I start off with number 1. It asks for F plus G of X. Okay, so when you write it like that, it just means atom. Sort of like a distributive property. Okay, so what was F of X? 2x minus 1. G of X is x squared minus 3x minus 6. So this was F, this was G. Copy it, right? Okay. F, 2x minus 1. G is x squared minus 3x minus 6. Here's atom. Okay, so just combine like terms, and I think I'll write it in order. Order is x squared, then x, then number, right? So it's just x squared, is that right? And then combining x, 2x minus 3x is a negative x. And then what? Negative 1 minus 6 is minus 7. That's all. That's pretty easy, right? Okay. Part B, same thing. It says f minus g of x. Okay, f minus g of x. And it's almost like a distributive property. So instead of adding, I subtract them. Same two functions. So I'll just take the same two functions and subtract. The thing that's a little bit tricky to watch out for is it's minus parentheses. Okay, you're subtracting the whole thing. So you have parentheses minus parentheses, otherwise you'll get it wrong. So it's 2x minus 1 minus parentheses x squared minus 3x minus 6. Okay, so this is F, this is G. just like over here. In fact, think of it as do the exact same thing, except change that plus to a minus, but keep paren. So 2x minus 1 minus parentheses x squared minus 3x minus 6. So you should distribute first, right? So 2x minus 1 minus x squared plus 3x minus 6, like that. Okay, now I combine like terms as usual. So negative x squared.
Would that be a plus 6?
Should be a plus 6. You're right. Thank you. I think I said to distribute. I didn't do it. So, right. So negative x squared. And then let's see. 2x plus 3x is 5x. And then what? Negative 1 plus 6 is a plus 5. Okay. That, and then what do they want for C? F minus g of 0. Okay, now this is f minus g of x. So it's the same function. So all I do now is just plug in 0 here. Okay, I don't start all over. You don't have to reinvent the wheel, so to speak. Okay, the f minus g. I already did f minus g right here, so why do it all over again? Just take this answer and plug in 0. So negative 0 squared plus 5 times 0 plus 5. That's 0, plus 5, so it looks like an answer 5. Okay. No big deal there, hopefully. All right, so let's see, 3, 5, 7. They don't really look that much harder. See, 3 has m and f, so you subtract m minus f and then f minus m. Okay, no big deal. So what looks hard? None of them really looks hard. How about I do 5? Okay, f k of x multiply k f of x multiply f k1 minus k f2. Okay, try 5. So 5 fk of x. It means you multiply them. Okay, so f, oh, we just did f, right? That was 2x minus 1, wasn't it? That didn't change. In problem 5, f of x is 2x minus 1 up here by my thumb. Times k of x. K of x is just 2. That's very easy. Multiply by 2, 4x minus 2. That was easy. B, switch it around, k f of x. Isn't that going to be the same thing? Multiplication is commutative, right? So k is just 2, f is that. So same thing, 4x minus 2. That was really easy. And I'm trying to make it look more complicated with C, but it really isn't. Fk of 1 minus kf of 2. They write it like this. Aren't they the same function, though? They're both that. So I'll plug in 1, plug in 2, and then subtract. Right? Same function. So 4 times 1 minus 2 minus 4 times 2 minus 2. Right? This is fk of 1. Fk and kf are the same function. So I plug in 1, 4 times 1 minus 2, I plug in 2, 4 times 2 minus 2, and then subtract. Okay, so 4 times 1 is 4, 4 minus 2 is 2. 4 times 2 is 8. 8 minus 2 is 6. So 2 minus 6, negative 4. Okay. Okay, then I think I'll do 7 and then we'll break. So you have a division of functions. 7a, f divided by m of x minus m divided by f of x. Then for part b, you just plug in 0 after that. Okay, let's see what's going on with that. F divided by m of x minus m divided by f of x. So what is m? M is x squared minus 9. And f, we've done that several times already, 2x minus 1. Okay. So f divided by m, 2x minus 1 over x squared minus 9, minus m divided by x. I just flip it, don't I? X squared minus 9 over 2x minus 1. Okay, so f was 2x minus 1. M was x squared minus 9. So f divided by m divided by x. That's it, folks. Don't try to combine it. Leave it. No reason to change it. Part B, plug in 0 to that expression. So f over m of 0 minus m over f of 0. I just plug in 0 everywhere. So 2 times 0 minus 1 is negative 1. Put a 0 there, that's negative 9. Minus negative 9 over negative 1. 5 negatives, a quintuple negative, I guess. How many times have you had a quintuple negative in that? So that's positive. 1/9 minus 9. Or 1/9 minus 81 over 9. So negative 80 over 9, I guess. Yeah. Get a common denominator. Okay, so those are fairly straightforward. Less straightforward are the composition of functions. Okay, so starting with problem 9. Okay, so I'll do those after we break. Okay, so we'll take a break right now. Let me check the chat real quickly. Are there retake exams? There are no makeup exams, but you get to drop an exam. Somebody asked about that. Okay, so dropping an exam, to me, that's better when you do it that way. Okay, so we'll stop. Let's see, 5. Okay, 12:10. Start up again at 12:10. Okay, so break until 12:10. I'll also put that in the chat, and I will disappear also. Okay, folks, it's 10 after, so we'll go ahead and get started with the second half. All right, so we're doing some composition of functions. Okay, so I'll do some, and then I'll stop after a while and let you do some, and then we're done for the day. Okay, so the composition of functions is definitely harder. 9 until the end, I think. We start off with number 11, I guess. A, B, C, D. I'll do a couple of them. So they do all these different things here. Okay, so 11. About A. F of x is equal to x squared minus 3x minus 4. G of x is 2 minus 3x. And don't worry about it if you can't see it. Okay, they want f of g of x. The one that looks like fog, that's f of g of x. You have a function inside a function. Okay, so how do I do a function inside a function? Okay, leave alone the f, the left paren, and that right paren. So inside is supposed to be g of x. But instead of writing g of x, I put what it's equal to, which is this stuff. 2 minus 3x. Okay. And now this complicated thing goes right over here in parentheses and here in parentheses. So whatever's behind my pen, this pen, is going to be squared minus 3 times the same thing minus 4. So here we go. 2 minus 3x squared minus 3 times 2 minus 3x minus 4, like so. Okay. So this thing in parentheses goes right there, you square it, minus 3 times that same thing minus 4. Okay, so I just clean it up. Okay, so I square this expression, 4 minus 2 times 3 times 2, 12x plus 9x squared, using the shortcut for the square of a binomial. A squared minus 2ab plus b squared minus 6 plus 9x minus 4. All right, so combine like terms, 9x squared. And then x's are minus 12x plus 9x is a minus 3x. And then numbers, oh, I have a 4 minus 4, so that's 0, right? That cancels out with that. And then I just have a minus 6. So that's it. So that's fog, f circle g of x. Then you want f circle g of negative 2. This is f circle g of x. So f circle g of negative 2, I just plug in negative 2 now. So 9 times negative 2 squared minus 3 times negative 2 minus 6. That's 9 times 4, 36, plus 6 minus 6, which is still just 36. Okay. And then they reverse it, they want g circle f of x. So by definition, that's g of f of x. G. So instead of writing f of x, I write what it's equal to. So what was it equal to? That thing, x squared minus 3x minus 4. That goes right in there. G of f of x, x squared minus 3x minus 4, f of x. And what does g do? G goes 2 minus 3 times whatever's inside parentheses. So 2 minus 3 times whatever's inside parentheses. So that x squared minus 3x minus 4 business. So distribute 2 minus 3x squared plus 9x plus 12. 2 minus 3x squared plus 9x plus 12. And let's see, 2 plus 12 is 14. Negative 3x squared plus 9x plus 14. Okay. All right, and then they tell me to plug in something. So once again, they want you to plug in negative 2. For number 11, G circle f of negative 2. G circle f of negative 2. Plug in negative 2 right there and right there. So negative 3 times negative 2 squared plus 9 times negative 2 plus 14. Okay, so that's negative 3 times 4. Negative 2 squared is 4, right? So negative 3 times 4 is a negative 12 minus 18 plus 14. So whatever that is, negative 16. Yeah. Okay. Gosh, I'll show you one more of those types. So I just did A, there's B, C, and D. Oh, how about I'll do D? F of x is 3x minus 4. G of x is x plus 4 divided by 3. So letter D. F of x is 3x minus 4. G of x is x plus 4 over 3. They have it in parentheses, but it means the same thing as this. Okay, so they want fog f of g of x, f circle g of x. So inside I put that mess. Okay, so what does f do? Whatever's behind my finger goes right here in parentheses. So 3 times x plus 4 over 3 minus 4. So take a look what happens. 3's cancel. X plus 4 minus 4 is just x. I'm back to where I started from. Which automatically means, whoops, f circle g of negative 2. If you plug in negative 2, you're just at negative 2. Okay, then they want G circle F also. Golf, G circle F of X, by definition, is G of F of X. Okay, so F of X goes right here, right? So what is F of X? This thing, 3x minus 4. And now whatever is behind my pen, that thing behind my pen goes right there in parentheses. Okay, so it goes there, 3x minus 4 plus 4 divided by 3. But what do you notice here? 4's cancel out. I have 3x divided by 3, which is also x. I get back to the original x. which therefore means G circle F of -2 is also automatically -2. Okay. Problem's finished, but this is actually going to lead to something in the next section. That means these two functions are what's called inverse functions of each other. They're inverse functions. If you do one function and then immediately do the other, you get back your original value of x. It's the undo button. It's like when you undo an operation on your computer. Okay, Control Z, I suppose, as it were. Right? Oh, I made a mistake. Can I get back to where I was? Sort of. Okay. So if I do f of g or g of f, you get back your original x. Okay? They're called inverse functions of each other. You don't have to write that down. I'll write it down when we get to that section, which is probably tomorrow. Okay. So that's how that works. Okay, I'll do a little bit of 13. All right. So they got f and g. Find the domains of f circle g and g circle f, and then compute all of the following. Okay, so it looks like a slightly more complicated function. Let's see if we can make heads or tails out of it. F of x is 3x minus 4 over 3x plus 3. G of x plus 1 over x minus 1. Come up with f circle g and g circle f. Okay, they're very messy. F of g of x. So g of x goes inside. Okay, so that tells me right away x is not allowed to be 1, right? That's not allowed. And now this big mess goes right here and right here. That's the way the function works. 3 parentheses minus 4. 3 parentheses plus 3. What goes inside the parentheses? X plus 1 over x minus 1. Like that. Okay, that looks real bad. Let's see if we can make it look any nicer. Well, I can make it nicer by multiplying top and bottom by x minus 1, common denominator. Make it look nicer. And then if I distribute, I get a cancellation, right? So that's going to cancel that. I have 3 times x plus 1 minus 4 times x minus 1. 3 times x plus 1 plus 3 times x minus 1. Okay, makes it a little bit nicer. So 3x plus 3 minus 4x plus 4 on top. On the bottom, 3x plus 3 plus 3x minus 3. Okay, clean it up. So on top, what do I have? Negative x plus 7, I believe. The bottom, 3 minus 3 cancels out, so I just have 6x. Okay, so the domain, or D. Okay, so back over here, I was not allowed to plug in 1. Here, I'm not allowed to have 0. So set of all real numbers minus a set consisting of 0 and 1. 1 is no good from over here. 0 is no good over here. Okay, then G circle F. G of f of x. Okay. So replace f of x with what it's equal to, all this stuff. 3x minus 4 over 3x plus 3. And this mess goes there. So it's going to be mess plus 1 divided by mess minus 1. Mess plus 1, mess minus 1. And here's the mess. 3x minus 4, 3x plus 3. 3x minus 4, 3x plus 3. Okay, so right away, again, I can say x cannot be negative 1. Negative 1 makes the denominator 0 here. Okay, and again, how do I make it look nicer? Multiply the top and bottom by 3x plus 3. Like this. Three x plus 3, 3x plus 3. Distribute, 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 distribute. Okay, if I take 3x plus 3 times this, the 3x plus 3 cancels out, so I just have 3x minus 4. Plus 1 times that is just that. And well, the bottom's the same thing, except there's a minus here, right? So that's still going to be 3x minus 4. Except minus parentheses 3x plus 3. So clean it up. 6x minus 1 over 3x minus 4 minus 3x minus 3. 3x minus 4 minus 3x minus 3. Looks like the 3x's canceled out. So 6x minus 1 divided by negative 7. Okay. All right, so there's no trouble here, but there was trouble when plugging in negative 1 here. So the domain for this one is all real numbers minus the set consisting of negative 1. Like that. Okay, so I actually snuck in, I'm done with A. I did that. And I'm sort of done with E. I put f of y, just change everything to y, actually. Okay, so f of g of x was right here. They say for g of f of y, so E, g of f of y, you just change that to a y. 6y minus 1 divided by negative 7. No big deal. C is f circle g of 2. So f circle g was right over here. I just plug in 2. Here and here. So negative 2 plus 7 over 6 times 2. 5 over 12. That's all. Okay, so I think that's all I wanted to show you for that. I think you got the idea for that one. Okay, then all we have left are 15 and 17, and we're done with the section. You have M composed with itself. I won't do the whole thing, but I just set you up with it. 15. So M of x is 2x minus 1 divided by x minus 2. Okay. X minus 1 divided by x minus 2. Let me do the harder part, m of x, b. M circle m of x. Yeah, you can have the function in the same thing there. So what is m of x? This thing. And now what do? Cover it up. Whatever's behind my ruler here goes right there and right there. So this mess is going to be 2 times a mess minus 1 divided by a mess minus 2. Right? You just think easy. Suppose it says m of 1. You put a 1 there and a 1 there. If it said m of pi, you put a pi there and a pi there. If it's m of a mess, the mess goes right there and right there. I do have a mess. So that mess goes right there and right there. 2x minus 1 over x minus 2. 2x minus 1, x minus 2. I'm going to let you clean that up, but to do the rest of the problem is actually not so bad. Okay, I'm going to go back to A, where it asks for m of 7. So first, I want m of 7. I plug in 7. So 2 times 7 minus 1 divided by 7 minus 2. So that's 14 minus 1 is 13. 13 over 5. So m of 7 is m of 13 over 5. So I put 13 over 5 here and here and clean it up. 2 times 13 over 5 minus 1. 13 over 5 minus 2. Okay. Put 13 over 5 right there and right there. Okay. And again, we can make it a lot nicer by multiplying top and bottom by 5. Highly advise that. So that 5 will cancel that 5. 2 times 13, which is 26. Minus 1 times 5 is 5. 5 cancels out. 13 minus 10. So 21 over 3, which is 7. So it looks like the answer is 7. Okay. Okay, finally 17. So I'll do 17. What time is it? Only 12:35, so we'll be done pretty early, I think. Okay, I'll do some of 17, give you something to do in class, and then we're done for the day. Okay. This is probably one of those where you have to just write down what I say. I won't be able to write it on paper or anything. So they're giving you 3 functions, f, g, and h, and they're asking you to evaluate all these different things there. Okay. So you base it off the functions. Okay, so A, f of g of 3. Now, by order of operations, you do inside out. So first g of 3. So where is g? Here we are. G of 3 is 0. Okay. Maybe I can write this. And 0. So now I'm doing f of 0. So where's f? Here's f. F of 0 is 1. So final answer is 1. See how it works? Inside out. G of 3 first. So the g function, g of 3 is 0. So I'm doing f of 0, which is 1. Okay. How about I do d? H circle g, looks like hog. It means h of g of 2. Maybe I can write that. h of g of 2. H of g of 2. So first I find g of 2. G of 2, 1. So now I want h of 1. So here's h. H of 1 is 2. H of 1 is 2. And there we go. And the last thing I'll do probably is f. That looks like the hardest of them all. There's 4 functions involved, g, f, h, f of 2. Okay, so maybe I'll write this here for f. I'm going to write it over here. It's g of f of h of f of 2, paren, 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 paren. G circle f, circle h, circle f of 2. G of f of h of f of 2. And you say that gets me all dizzy. It does, but if you just go by order of operations, you're supposed to do f of 2 first, right? Even though I wrote all that junk there, just focus only on that, f of 2. Then it's not so bad, right? And we just work our way up. So f of 2, f of 2, negative 1. Right? Okay, I can write it in my book. This is negative 1. So I got rid of that. So now I'm doing g of f of h of negative 1, paren, paren, paren. Sorry if I can really write this. Okay, so that f of 2, right? Pretend you cross it out, change it to negative 1. So now I'm doing h of negative 1. H negative 1 is up here. So where's here? 3. So now I know this is 3. I've gotten it down to g of f of 3. That h of negative 1 is now 3. Whoops. What happened there? Let me try to get back here. If I can't get it, then I guess I'm done. Okay. G of f of 3. So f of 3. F 3, 1, let's see, 1, 2, 3 is way up here. So where's here? 1, 2, 3, 4. 4. And then I'm done after I do g of 4. I want g of 4. G of 4, 1, 2, 3, 4 is down here. Looks like it's negative 3. We just do one at a time. Do the innermost. I did f of 2. That came out to be negative 1. Then I do h of negative 1. That was 3. Then I do f of 3. That was 4. And then g of 4 finally is negative 3. And there we go. And that's about it. Okay, so that's about it. I don't see anything in the chat, so I'm finished. So I'll give you something to do. From the book, by the way. So again, I'm still on schedule. So I'm up to here. So tomorrow, 3641, quiz on Thursday. Remember, we have a 4-day weekend, no school Friday. We don't have school Friday anyway, but if you have any other classes, no CSM classes on Friday or Monday for a 4-day weekend. Okay. All right. So right now in class, please, I'm going to have you go back on page 190. Yeah, 190. I want you to do problem 2. If you have the book, just go from the book. If you don't have it, I'll hold it up for maybe 20 seconds. Please make a note of problem 2. And you need all the functions above it also. So do 2a, b, and c. Just put your answer to a, b, and c, then you can leave and I'll see you tomorrow. So just problem 2. F times h of x, h divided by f, and then f divided by h of 1. Okay. H divided by F, you don't really have to do a whole lot except just write it. Okay, so again, just problem 2, A, B, and C. And to write an exponent, use the up caret. As I mentioned before, if I have time, I'll put that also. Again, just problem 2. Take a picture on your cell phone now or do a screenshot. A, B, and C. And the only functions are f and h. So f is 2x minus 1, h is x cubed. So A, just multiply them. B, you divide them. You just put one on top of the other. And then C, f divided by h, and then you plug in 1. Okay, I'm putting the book down because it's too heavy. Okay, I'm going to stop recording also. So no need to record anymore.